Okay, let us start with the next topic, gas turbine combustors. Okay, the second topic in the unit number 2, second major topic. We have three topics: intakes, combustor, and nozzle. The first intake portion over. We are start with the combustion chamber. Today we are going to start with the combustion chamber portion. So, as you know, the basics of chambers are what is the need of combustion chambers in a jet engine. What is the requirement of a chamber in a jet engine? Anyone? What is the requirement of a combustion chamber in a jet engine?
So to produce thrust,
Okay. So nozzle is meant for the generating thrust. Am I right?
To burn the fuel.
No, burn the fuel and generate hot gases in terms of generating thrust through the nozzle. Okay. So the purpose of the combustion system in the jet engine is to increase the thermal energy of a flowing gas from by a combustion. So as we mentioned, air from the intake and compressed air from the compressor will be taken to the chamber that will be adding the fuel. The fuel along with the compressed air gets to get combusted or heated, and that burn tends to generate some hot gases. The hot gases will be taken to the nozzle and then will be expanded and turbine and then to generate thrust, turbine nozzle. Okay. So that with respect to that, we will be having your component known as the combustion chamber or combustor that is meant for burning the fuel along with the combusted air so that it get combusted and hot gas is generated. So this is an exothermic reaction. Always combustion is an exothermic reaction. What do you mean by exothermic reaction? What is the exothermic reaction?
Sir, which gives away heat.
Yes. Okay. Gives away heat or liberates heat. Endothermic means absorbing it. So we have endothermic and exothermic. Exothermic liberates heat or heat away the it liberates generating heat or what is that? Removing away the heat away the gas. So gases will be removing and it will be generating gases, producing gases, and liberating energy. So there are known as kind of some exothermic reactions between the fuel and oxygen or oxidation in the flowing stream. So mostly it will be taken in the chamber or combustion chamber or the burner. It is also used to called as the main burner. Or in some cases, we'll be having one additional burner. It is meant for augmenting the thrust known as afterburner. So if you are using the reheater or regenerator or augmenter can be used in the supersonic aircrafts. So you can able to see the diagram. There will be having entire system of compressors of known as the combustion chamber. So we have number of holes or veins or will be available. Through that only we will be allowed to flow the air into the stream of flow of stream air into taken into the system. Primary air, secondary and dilution or tertiary airs. Three type of air stream will be. We have air. Three zones are available. Through the three zone of the stream of air flow, air will be allowed to flow into the chamber. So the other common like fan, snouts, and other yeah, the correct joints, sealing links will be all additional equipments or accessories. Sorry, the connecting agents, elements we'll be having in the chamber. So we'll be discussing on the more on major components. So the major component is here is known as called as a burner or the flame tube. Sometimes we used to call this the flame tube also. So inside the tube only we are having the flame tube. We are the application of the flame. Pilot flame or spark flame or propulsion flame tends to give some energy of heating for generating hot gases. So that it is called as a flame tube. So in that you can able to see diagram. You can have the primary zone. There will be a number of holes are available. That is that's through that air we will allow it. That is called as primary zone. Then we have secondary air holes. That zone is the secondary zone, and then we'll be having a dilution of the tertiary air holes or tertiary zones. Along with having air casing also. So this is the major overall arrangement of a basic combustion chamber. So basically, combustion is a chemical reaction, exothermic reaction between the fuel and oxidizer tend to generate gases. There are three phases of combustion. There will be a process called initiation, propagation, and termination. So we got to initiate the combustion process and propagating the flame or stream stream of flame spread that to generate or making a proper burning, then we have to go for terminating the hot gases, generating energy. So the function of the chamber, the major function of the chamber is to provide complete combustion. So combustion should be complete, should not be incomplete combustion. It should not leave any unwanted gases in the stream. It should provide the proper combustion at the end. So complete combustion is needed. That is the major combustion of the combustion chamber. Then as well as there will be a losses. The total pressure loss should be moderate. So there won't be any more pressure losses or stagnation pressure losses. Should be avoided. The pressure should be percentage should be very less or it should be moderate in level. That is a second function of the chamber. The third one is stability. So due to the freedom of from the flame out, the flame spread or moving in the stream of flame tends to causes some instability of flow, combustion instability due to losses or due to some loss in the temperature and pressure. So that has to be nice. So stability in the combustion process is very important. Then at the in-flight reliability, it should be reliable for the in-flight operations. Then temperature distribution should be proper at exit with no hot spots. It should not have any hot spot at the end of the combustion. Then the length and short, it should be as small as in comparison in the size as well as in the length and diameters. Similarly, widespread operating range of mass flow rates and pressures and temperatures. That is another requirement of the combustion chamber. So it should be free from pollutants, air pollutants, environmental air pollutants. That is the certification of established environmental limits of air pollutants. That is the next function of the combustion chamber. So as I mentioned earlier, the combustion starts with initiation and propagation and termination. So initiation in the sense, so first you are supposed to allow to spray the fuel in the form of fuel droplets or final droplets. Third, further we use injectors or atomizer. Injector is mentioned for atomizer is used to atomize the major droplets into small droplets. The splitting of major atoms into small droplets, small atoms is known as atomizations. So it is meant for atomizing, not only for injecting the fuel droplets as well as for atomizing, not only injecting fuel along with the oxidizers. So that is the first step, spray of injection atomization. Then after that, once it tends to allow to flow the stream of air stream or oxidizer flow stream with the fuel, that is not these two tends to have some evaporation. So after that evaporation, mixing of that fuel evaporated air with the fuel will be mixed together. Sometimes mixing may takes place before evaporation also. After that, we go to ignite. So ignition. So we go to allowed to provide some ignition. Due to the ignition, there will be a proper combustion takes place, and it tends to provide generating heat releases. So sometimes that exhaust gases or mixed gases will be again mixing with the combustion products. The fuel will be mixing purpose. Then again we will get answers. At the end, after the combustion, it will be taken to the turbine as the hot gases. So this is the model of the turbine combustor and turbine in a gas turbine engine. The gas turbine, the fuel droplets, air from the compressor will be air will be taken into the system of flow. Both will mix together or vaporize together, and after that evaporation, then mixing again, it can mix together. Then ignition takes place, and the generating heat releasing energy, high amount of energy of gases. So that has may be again products can be mixed again with the fuel droplets again to enhance the process. Then at the end, we'll be getting the required amount of the exhaust gases into the to allow to flow into the turbine. So this is the arrangement in the combustion chamber process or combustion process in the combustion chamber. So as I mentioned earlier, there will be three zones: primary zone, secondary, and tertiary zone. So the primary zone, we are allowed to flow. The air is called the primary air. This is the main combustion air. Primary is the main combustion air. That is that it is the highly compressed air from the high pressurized stream of compressor, often delivered this way by the diffuser. So that the air can distributed from the diffuser will be taken to the compressor. It is a highly compressed air that taken from the compressor with high pressurized flow, often distributed in the diffuser. That air is spread to the main channel of the dome of the combustor and the first set of holes. So that diffused air taken from the compressed air or diffuser is accelerated, will be dislated by the diffuser, but it will flow into the main channels in the dome of the combustor and the first set of the liner holes. This air is mixed with fuel and then combustor. So as I mentioned earlier, we have the primary air shown, secondary air shown, and radiation shown. You can able to see the diagram with some percentage, 20%, 40%, and 20, 40, 20, 60 plus 20, 80, like that. So 80 plus 20. So 8%, again 20 is split into 8% and 12%. That 60, 80% divided into 40, 20, and 20. 60 plus 20, 80%, and 80, 20 is 20% divided into 12 and 8%. So you can able to see the diagram. 80% of follow stream will be flowed to that one side stream. That's split into three components: primary, secondary, and tertiary as 20, 40, and 20. And the remaining 20 will be allowed to flow to the entry internally. That is split into two portions as 8% and 12%. So as I mentioned earlier, primary air zone will be allowed to allow some amount of air that is main, is called as the main combustion air, that is allowed to flow to the stream of air. Is a highly compressed air from the high pressure compressor taken. That will be taken from the dissipating air from the diffuser to the compressor. So that is fed into the main channel in the dome of the chamber and the first set of liner hose. That air is mixed with fuel and then it will be get combusted. Second zone is called as secondary zone or intermediate air flow stream zone. So there you can see there the diagram. Again, you can have the swell, that some amount of stubble flow stream with the flame tube ignition plug. We are allowed to ignite some using igniter plug for ignition purpose. Then we are using the fuel nozzle, allow the fuel to flow into the system. Then the airflow stream allow 80%, 20, and at all discuss 20, 20, 40, and 20. See that the 20 meant for primary and 40 is for the cooling, and the remaining 20 is for dilution. So the primary air tends to allow with the fuel supply. Then that will 20% that causes some amount of stream of air to flow. That causes some air to mix with the fuel. Then you take into the fuel with the 40% requirement for cooling the air coming from the primary zone, and remaining 20% is the hot gases taken after the cooling process, the diluted, that in the form of 20% in the form of dilution zone will be taken to the system of the combustion chamber. So that second stream of flow is that secondary air flow or intermediate air flow. Intermediate air is the air injected into the combustion that is meant for combustion. So that thrown through this second set of air inner holes. So as I already mentioned, primary air goes through the first set, secondary air through the second set of the liner holes. This air completes the reaction processes, cooling the air down and diluting the high concentration of carbon monoxide processes, cooling air down from the diluted high concentration of the carbon monoxide and hydrogen also. So that is objective of providing the second stream of intermediate stream of to the combustion chamber. 20, 40, and 20 system with the flame tube, primary, secondary, and tertiary solutions. Then third portion of stream is dilution zone. So the dilution air is flow injected through the holes in the liner at the end of the combustion chamber. So see the diagram. So the last end we have the sun liner, that is for the dilution holes. So end of the combustion will be having certain liners. Through the liners will be allow the air to flow. The dilution air is flow injected through the holes in the liner at the end of the combustion chamber to help cool down the air to before it reaches the turbine chambers. So as I know that air coming out of the combustion with high energy, high temperature, so that air has to be cooled down. That cool down can be taken place then get through the holes in the liner of the chamber. You put the air before the turbine stages, otherwise it will be eroding the turbine passages or damaging the turbine blade sections. So in order to overcome this problem of that high temperature stream of passage of hot gases from coming out of the chamber, which will be affecting the turbine blades or turbine stages, we have to cool down. For that, we will be allowing certain amount of air to flow to the dilution airflow injection systems. So that is very important. You have to provide a proper, carefully allowed to flow the system of flow to produce uniform temperature profile designed in the combustion. So you can see the diagram. There will be injection evaporation. So whenever the fuel is injected, they are allowed to flow. There will be a evaporation takes place with the flame and or ignition takes place. So again, that stream of air will be taken from the primary portion, will be mixed with the secondary stream of flow. Then again, the temperature control of the combustion, proper combustion takes place. At the end, leaving of the chamber will be, at the end of the chamber, will be allowed to flow one more stream is called as dilution zone, will be allowed to tertiary air stream flow that tends to mix with that secondary air flow. That about to causes, that tends to causes some cooling down or dilution of the air coming out of this the air flow stream through the holes in the liner at the end of the combustion chamber. Cool down. So the cooling airflow is that is injected is very through small holes in the liner to generate a lower of stream of coal to protect the liner from the combustion chamber. Cooling air is the air is cooling air is the flow that is injected through the small holes in the liner to generate a layer film or cool air to protect the liner from the combustion temperatures. In some cases, as much as 50% of the inlet air is used as cooling air. So if you require more amount of cooling, if you require more amount of cooling of the stream, sometimes you'll be allowed to flow 50% as much as 50% of inlet air, which is used as cooling air to cool down the system of combustion chamber. So these are all the about the chamber process and the cooling system, how the process takes place in the combustion chamber. So the combustion starts with the injection of the fuel spray injection system by providing the fuel as well as they are allowed to flow the air to the stream first option. Then the injector, that fuel should be atomized properly. Not only injected, it should be atomized. So injection and atomized flow should be mixed with the the airflow coming out of the stream will be evaporation. The evaporation is mixed with the air, again will take place when they are igniting, then will be releasing energy. The hot gas coming out of the stream will be again, products will be again mixed with the fuels of already they are supplied and the air stream flow also. Then that will be tends to allow to stream to the delivery before delivery to the turbine. So there will be a primary air, secondary air, tertiary air. Primary air is the main air. It's a highly compressed air from the high pressure stream of flow combustor, which is taken from the diffuser. When they already diffused by the diffuser, that is taken to the compressor, and that will be fed through the main channels in the dome of the chamber and the first set of liner holes. And the air is mixed with fuel, and then it will get combusted. Then there will be a secondary air. The secondary air is into the combustion zone through the second set of liner holes. Primary air will be first set, and second will be liner holes only. This air completes the reaction processes and tends to cooling the air down and adding the high percentage of the carbon monoxide and the hydrogen present in the system. The dilution is the airflow injected to the holes in the liner at the end of the combustion chamber. It is used to cool the air before it reaches the carbon stages. More amount of air can be used. Sometimes 40%, sometimes 50% air will be allowed to flow to cool down the hot gases coming out of the system of chamber and the secondary zone. And there will be a uniform temperature profile design in the chamber should be allowed to flow. And cooling air is in the form of 50% range. So you can see the diagram. This indicates the direction of flow of stream blue and red color with different liners and different line holes provided in the opening or orifices around these three flame tubes. That amount of flame injector, flame ignition flame system, ignitor, and heating and cooling of first. So the combustion process normally takes place. The membrane is a two circulation zone. By providing a vessel plate, it's a blood body in the blow. We are providing a blood for which will provide a swell supply and so on. A swell one also attached in the front panel, so that is running the cylinder inside the chamber. This brings down the axial velocity from 1p2 to 40 to 40 to the compressor. The flow of axial velocity should be reduced, so that swell will be tends to enhance the process. Now the buffer, the flame tube and the swell are combined to give primary combustion. It creates low fall loss region at its peak. where the fuel may be in the form of gases. So this spiral flow together with the cross flow setup, the strong vortex region will help in optimizing the fuel. So not only the spiral stabilized flow, the sliding swirl is meant for stabilizing the flame stabilization method, one of the flame stabilization method that is meant for not only this combined with the cross flow setup, the strong vortex region will help in optimizing the fuel and mixing with the air coming in the stove through side entry holes and the air fuel air ratio may be kept around this recommended value. So for the secondary mixing after combustion, there will be a flame tube with holes on the outside, which set up a cross flow pattern. So it is giving a good mixing and inside the tube that is used, very much used. If the primary zone geometry is shape and size locus are fixed, it is time for dilution of the hard combustion products. So we have to provide the fixed. So this flame tubes continuously further behind the outer holes for two-stage mixing before the hot gases can go to the air. Outer casing allows the inner can to form and under the duct for secondary and tertiary air. The inner can or inner tube can have small holes in an array in between the mixing zones to permit air entry in tangential direction to the casing wall, thus giving a cool air from which protects and extend life of the casing material as well as outer casing and all the life of that. In case in way it will extend the life of the turbine material also. The inner can has small holes in an array, is number of holes in between the mixing zones to permit air entry in the tangential direction the casing wall. So the annular combustion chambers are expected to be used more and more as like fuel gas turbines or to be applied in small aircraft engines. The annular combustion chambers are expected to be used more and more as the gas turbines to be applied in small aircraft engines. So it requires less cooling air as the total combustion chamber surface area. So this is the same surface area of the chamber combustion is less than the first two cases. So we require a less cooling air to the total combustion chamber of the area, lighter and hence quality for operation in military aircrafts. So sometimes a reheat chamber is also essentially an annular combustion chamber. Its temperature and velocity profiles are not as highest that one. So that about the combustion processes inside the combustion chamber. Let me continue with the topic, the types of combustion chamber. So today we'll be having class till 4, okay, so till 11, sorry, 11. So next we'll be compensating the last hour missing hour also. Not missing hours, not assignment was given to you. So the types of combustion chambers, there are the combustion chambers can be classified in various stages.
Sir,
Yeah.
at 10:50 we are having a flight dynamics class, sir. Flight dynamics 2.
Who is
Sir,
handling?
sir,
Who is handling?
I and Nandil, we both have, sir, at
Who is
10:50.
who is the faculty?
Sir, faculty is Sarvana Kumar, sir.
Okay. Yeah, 10:50 handling. No problem.
Okay, sir.
I will continue. Okay. Okay, then types of combustion chambers. So combustion chamber can be classified based on various cases. The first one based on location, second based on speed of operation, and based on the flow direction. So based on the location of the combustion chamber can be classified as main burner or afterburner, and based on the speed, it can be classified as subsonic combustion chamber or supersonic combustors. It can be classified into can type, annular type, and can annular type. And based on flow direction, it can be direct flow type or reverse flow type. So these are major classifications. So main burner, afterburner, as I mentioned earlier, if the combustion chamber or burner is meant for used as the normal engine burner meant for heating our purpose, that is called as main burner. If you provide the one more burner that is additional to the main burner, it's meant for enhancing the thrust or thrust accommodation. You'll be having a burner that's called as afterburner. The combustion chamber based on the speed, subsonic and supersonic, and can type, annular type, and cannula type based on the arrangements or the shape. Whether we having only one tube, it is called as can type or tubular type. If you have annular bonus, that is called annular number of bonus surrounding in the place in the manner such a way, it is annular manner, it is called annular chamber. If you have combination of these two, can type plus annular type, then it is called as cannular type. And based on flow direction, if it is a direct flow or reverse flow, you'll be allowed to flow the gas stream with the chamber in the form of direct and inward flow, reverse flow. That type of flow is called as based on direction. We can classify into direct flow combustion chamber and reverse flow combustion chamber. So first, you can see the diagram. The diagram you can able to understand what is the meaning by reverse flow, what is meant by direct flow. So while coming to the straight flow or direct flow, both fuel as well as the oxygen both are in the same direction. The supply stream, fuel supply stream, you can able to see the diagram, and the oxygen also flow, gas flow stream, both are in the same direction. If the fuel is in one direction or the reverse other side direction, we allow the air to flow, then it's called as reverse flow stream of arrangements. So coming to that type of arrangements other than the flow stream, that way like can type or annular type or tubular cannular can have the various classifications such as annular or cannular combustors. Okay, as you requested, I better to stop the class now. Okay, fine.